aunties and nephews, uncles and nieces, and anyone who just happens to be tuning in. Welcome to video 2 of my Spotify project. So let's just jump right into it because I'm assuming that you guys are just coming here from the first video. So if you guys remember in the last video, we actually ended on another file when I was saving my data sets to these pickle files. And what these pickle files do is that it just allows for data sets to be transported from or be referenced from one file from another file. So you upload a data frame, obviously do whatever you need to do with it using Python, and then you save it to a pickle file, and then you can read the pickle file in another file in another Jupyter notebook or another Python file, and then continue your analysis or your model building or whatever you need to do in that particular file. So it's just an easy way to transport data. So as you can see here, this is as you can tell by the title of the Jupyter notebook, it is Spotify data analysis library data. So this is all the songs, all the artists, all the playlists that I have in my library. At the time that Spotify wrapped 2023, which I believe was in December. So at that time, this is all the songs and playlists I had and artists I had in my catalog, my Spotify catalog. So you can see here, library tracks, library artists, library albums, and then this is a data frame that I will be using to kind of map obviously these parameters: energy, danceability, loudness, speechiness, acousticness, etc. I'll be using this data set to map it to whatever songs are in my library, and whatever songs are here, I'll be using them to mesh them together. So as you can see here, I get a working data frame which has the track ID, artist, and then popularity, danceability, energy, speechiness, liveliness, valence, tempo, and track genre. So basically all the variables that I want to focus on. There are more in this data frame, and I'll have the link to this where I got this original data frame in the description below. But these are just kind of the columns I want to focus on for this particular project. And so obviously this is me changing artist to artist name because I'm trying to join these two data frames. I'm going to join artist name with artist name and see what I get. But that's at the end of the video. But before we get to that, we of course have to do some analysis because this is a analysis video and an analysis file. So right here, we're going to start with my library track. So as of December 2023, I have over 2,500 songs in my catalog. I probably don't listen to half of those, but they're just saved in my catalog. They're liked songs that I have. So what I did is I got the number of unique artists I have in my library, which is 546, and obviously I did the same kind of method that I did in the last video where I got the value counts and only stopped it at 10 because top 10. And so obviously Drake, the Kid from the Six, is number 1. C Breezy number 2. Ye is number 3. Weezy number 4. Migos 5, Baby, and then etc. So what I did is did the same method, reset the index, get 2 column names, create a data frame, and then created again Plotly. Love these charts. Love these charts. Super interactive, super colorful, really easy to read. Love these charts. And I also did a bar chart because I love the 2 comparison just to see. Obviously, this is good percentage-wise, but this is good to compare, how much things differ by. So Drake is obviously, I have a lot of Drake songs, and ironically, not a lot of Chris Brown songs, which kind of, puts into my mind that I listen to probably these 81 Chris Brown songs a lot more than these Drake songs, because Chris Brown, as you guys know from my last video, empirically is my favorite artist and the artist I listen to the most. So right here we have library albums. As you can see, I have 97 unique albums, and this is basically, so the way this is that it's 97 unique albums. So if I have one song in my liked songs from one album, it counts the album. So let's just say C Breezy, Under the Influence, I have one song, Overtime, saved in my like songs, is gonna count me as having the album under the influence in my catalog. So that's the way that works. So it's kind of accurate, but maybe not. So as you can see, yeah, I get the top 10, and then various artists is just kind of like either A, artists that aren't on Spotify anymore, B, different two artists collabing for different albums that have different songs. So basically, I didn't really count this because I'm not entirely sure what very artist means. I don't know who that entails. But obviously, Drake's number one, Kanye is number two, DaBaby, Chris Brown, Uzi Vert, etc., etc. And so, obviously, I did this. My voice. Same thing. And then I got various artists: Drake, Kanye West, DaBaby, Chris Brown. And then I looked at that, and it's pretty. I'd say this is honestly about right. Excluding various artists, I'd say that this is about right because, yeah. Although Chris Brown's kind of lower than I expected, but this seems to follow, honestly. All right, so obviously items that I noticed, Drake is the most popular artist in my library at the moment, other than various artists, and yeah, that's really not a surprise. His catalog is his catalog. I'm not gonna get into that. So this is. Oh, sorry guys, hang on a minute. All right, sorry guys. So right now, oh my gosh. Okay, let me see if I can talk. Jesus. So right now, this is right here. This is doing an analysis on the genre album, the album that I was editing before I started all my other analysis. And here's the Library Tracks album, and I obviously had to rename artist name to album, artist to artist name from the Library Tracks, so I can join these two data frames, so I can merge it. So this merging is kind of difficult. So this merging originally joins on the artist name as outer. But as you can see, it creates a just bigger data frame because I do not have that many songs in my catalog. The numbers should be smaller than this or equal to this, and it's just way bigger. So basically what I'm doing here is I'm testing to see if I can just use a for loop just to go through each row and just match to the artist name. When merged, it doesn't work. So obviously, we reset everything, make sure everything is lined up. And this is a good practice to do, just so when you don't, or this is a good practice to have, just in case you guys mess up, or just in case something, function doesn't work out, like how this merge function didn't really work out how I planned. It's always good to just find backups and find alternatives to use instead of functions, which is why it's good to have a good fundamental knowledge of not only data science but data analysis and Python, and how you can use pretty basic Python functions to do things that already predefined functions can. So what I'm doing here is I'm trying it again on enter, and we get 3,200, which is closer to 2,500, but not exactly, because some things are repeating. For example, hold on repeats 5 times, and I do not have any of these artists in my catalog. I know this for a fact. I know this for a 100% fact. So what I decided to do is just create an empty list, and I said for element in library tracks track name, so the name of the song, and then if the element in the working data frame track name dot values, if it exists, if it's in it, if it contains it, then add the library track, add the track name to the analytics list. So add the row. So it adds artist name, album, track name, and URL. So basically, what this for loop is doing is it's taking for every element in library tracks track name, right? Let's just say the element is a song called I don't know, I'm on one, right? So that's the name of the song, is I'm on one. So if I'm on one is in this data is in this data frame right here, right here. If I'm on one, the track name is in this data frame anywhere, anywhere. It's gonna take it, and it's gonna add it, take it, and it's gonna add the row from my library tracks data frame to this empty list, which I can transform to data frame. So obviously, it's the same four columns as my library. You got artist name, album, track name, and then the song URL. But these are all the artist song names that are in this song. That are sorry, all the song names, all the track names that are in this data frame right here. And I thought that I was going to be good on this point, but then I realized that different artists can have the same name as a song, which is not what I want. So I was like, okay, well, that's not going to work. So what I needed to do was create another list basing it off of two parameters, because this is just seeing if the track name exists, which obviously it does, but it might not be the same artist. So what I did is I created another for loop that basically goes through each row in the working data frame, and then for each row, if whatever row you're on, the artist name is in my library tracks, and the track name, sorry, if the artist name is in my library tracks and the song name is in my library tracks, then I can append it to the empty list I created here. So now it's saying, let's say, let's just, all right, Rod Wave, so track name, Smile, artist, Rod Wave. If if the combination of Smile and Rod Wave are in the genre data frame, add it. If it's not, don't add it. So that's what this does. So eventually, I get a data frame which is 508 rows, which is about right, because this data frame doesn't really represent the type of music that I listen to, and it also doesn't represent all of the music in the world, because no data frame could ever do that. Or if it does, my computer just does not have the power to process it. Side note, I actually did find a data frame, or I found a few data frames that have a lot more songs, and the reason why I'm going to have to find some alternative methods is because my computer simply cannot handle it. Just cannot handle it. My Jupyter notebook is not big enough. I don't have enough memory, CPU, RAM, whatever you want to call it. My computer cannot handle this. So that's why I say it's good to know alternative ways to do things, because sometimes, the first way is not going to be the right way, and neither is the second time or the third time. So you got to kind of finesse your way. You got to try to find, that lane to sneak in and get the results that you want. So I am going to have to try another way, which means I'm going to have to redo some of my analysis on the first in the first Jupyter Notebook file, but of course I'll record that so you guys can all see, because it's all about making mistakes to get better. So, right here, so this is duplicated, so they have duplicated songs. So obviously, Jason Mraz, I'm yours, I'm yours, I'm yours. It's the same song, different track IDs, different things. And I'm basing this off of, or what I'm assuming is that Spotify changes, the speechiness, loudness, energy based on the songs that come out, and obviously they're gonna some of the parameters are gonna shift slightly over the years. So that's why I'm assuming that's why I'm yours appears 3 times. So basically, I just create a new genre list for the data frame, and I just remove the duplicates. So right here is my final data set, combination of the genre data frame and my library, all the songs that appear there, all the artist songs that appear there, all the track names that appear there, and obviously I got the parameters that I want. So this is where I'm going to have to redo some things, or I could, continue on this path, but I don't think that'd be the wise thing, because down the road I am going to have more data in order to build my model and to make some statistical inferences about. Because right now, this data set right here, with all the parameters, only represents about 6% 6.3% of the songs I have. So out of the 160, out of the 2,500 songs, only 160 songs are displayed here, are represented here, and that's only 6%. So even if I do some statistical inferences on this, figure out what distributions to use, which model to use, they cannot be used to generalize my entire library data set, because quite simply, it's just not enough. It's 6%. That's not going to be enough. So I will probably be doing some analysis on this, just because I am curious, and curiosity is what data science is kind of all about, and statistics. But as far as model building, as far as, further along in the project, I am going to have to go back and redo this or make a bigger representation of my data frame, or representation of my library, because you can't work with 6%. And I did find this website that I'm hopefully going to be able to scrape data from, that is going to give me it's going to give me all the songs I need, but really should also give me hopefully these parameters too. So I will record that video when I do it. So probably right after I finish recording this one, I'm going to save this video, and then I'm going to see about scraping the data and then doing some more data analysis. So per usual, thank you guys so much for listening in. Thank you guys so much for tuning in, and I will catch y'all later on the next video. Deuces.